All right, in this problem, we are going to need to add some of those zeros again. So our first polynomial is 5x to the fourth. And then we don't have an x cubed, so we need to add 0x cubed minus 6x squared. We don't have an x term, so add a 0, and then plus 1. Now, we also need to add a 0 to what we're dividing by. We have x squared, we do not have a 0x, and then a minus 1. So this adding zeros where we need it, we have to do it to both the thing that goes inside and the thing that goes outside. So this is the setup. These zeros help keep all of our like terms in nice vertical columns. It just makes the problem easier. So our goal is to get a 5x to the fourth. So up here we're thinking, what times x squared will give us 5x to the fourth? And I think we need a 5x squared. So 5x squared times x squared is 5x to the fourth. 5x squared times 0x is 0x cubed. And 5x squared times negative 1 is negative 5x squared. All right, draw the line and change the signs. 5x to the fourth and negative 5x to the fourth cancel. 0x cubed and 0x cubed also don't need those. And so we just have negative 1x squared. Now, we do need to drop this thing. But notice we're dividing by something that has 3 terms. So that means we need 3 terms here. So we're going to drop both of these things. And it's fine. We can do that if we need to. So now we're thinking, how are we going to get a negative x squared? What times x squared will give us a negative x squared? And I think just a negative 1 will work. So negative 1 times x is negative x squared. Negative 1 times 0x is negative 0x, doesn't really matter. And negative 1 times negative 1 is positive 1. Draw the line, change the signs. Negative x squared and x squared cancel. Those are both zeros. Negative 1 and 1 cancel. No remainder. And our answer is 5x squared minus 1. Okay, so that adding in zeros thing happens to both terms if needed. Now, the last thing we haven't talked about is remainders. On all of the problems we've done, I've pointed out that the remainder is 0. That doesn't always happen. So let me remind you of what happens when we're just doing normal numbers. If we take 8 divided by 5, that goes in one time, we multiply, we subtract, and then there's nothing else to drop down unless you do a decimal point, which we don't want to do that. The way we deal with our remainders is we take our remainder, 3, and we put it over whatever we divided by. So this is 1 3/5. We're going to do the same thing with these when we encounter a remainder. So let me show you this. This is a pretty short problem. X squared plus 8x plus 15 divided by x plus 4. So our goal is to get an x squared. So what times x gives you x squared? Well, it's just going to be an x. X times x is x squared. X times 4 is 4x. Draw the line and change the signs. And we get 4x. And we're going to drop the 15. Our next goal is to get a 4x. So what times x gives us 4x? Well, it'll definitely be a plus 4. So 4 times x is 4x. 4 times 4 is positive 16. Draw the line, change the signs, and we have a negative 1. There is nothing else to drop, so this negative 1 is a remainder. So here's what we're going to do with the remainder. Since it's negative, we're going to do minus 1. If it were a positive, I would do plus 1 over this thing that we divided by, x plus 4. That is your answer. So that's how you deal with remainders. You turn them into fractions and put them on the end, either with a plus or a minus sign. And that is how we divide polynomials.